Today we're going to be looking at factoring completely. So we're going to take a quadratic and make sure it's factored completely, meaning there's no factors within the factor. So we pull everything out of each individual factor. And to do that, what we do is we pull out a greatest common factor from the original quadratic. So if we're looking at this first one, 5x squared plus 15x minus 20. If we look at our first three, or our coefficients, a, b, and c, a, b, and c, we want to find out what is there anything that we can divide all three terms by? Turns out we can factor out a 5. So what we're going to do is we're going to factor out the 5, and we're going to rewrite the remaining quadratic that we would have. So 5 times what makes 5x squared? X squared, plus 5 times what makes 15x? 3x, and 5 times what makes negative 20? Negative 4. So that's our first step in this process. We factored out the 5, leaving us with a more simple quadratic in our parentheses. Now we're going to take this quadratic left in parentheses, and we're going to factor that. So our goal, we still need to factor. So this is going into our generic rectangle. X squared and negative 4 will be in our two diagonal squares of the generic rectangle. X squared times negative 4 gives us negative 4x squared. And we know it has to add to our middle term 3x. Our two values that add to 3x and multiply to negative 4. Positive 4x and negative 1x. We're going to go ahead and throw that in our generic rectangle and continue our factoring of our generic rectangle. So I'm going to pull out an x, negative 1, and 4. All right. Taking the dimensions of our generic rectangle as our two factors, we're going to rewrite what's in parentheses. That factored form would be x plus 4, x minus 1. And what we have to remember is this is the factored form of just what's in parentheses here. It's not the factored form of our original 5x squared plus 15x minus 20. So what we have to do is we have to bring down and make sure we include that factor that we originally pulled out. So our factored form is 5 times x plus 4 times x minus 1. Moving on to another example. 6m squared plus 24m plus 24. The process of factoring this quadratic doesn't change. We just will have that prior pre-step we want to look for if we can. So we want to look if there's anything we can factor out of 6, 24, and 24. Our greatest common factor of those three numbers is 6. So like before, we're going to factor out the 6 and write our remaining quadratic in the parentheses. M squared plus 4m plus 4. We'll now take this quadratic in parentheses and factor using our rectangle. M squared and 4. M squared times 4 is 4m squared. Got to add to 4m. Now, a common mistake is students want to go back to the original quadratic to fill in these terms. Remember, we've already moved on by factoring out a 6. So once we do that, we're going to start using this expression versus our original. All right, so what adds to 4 multiplies to 4? Adds to 4 multiplies to 4. We have 2m, 2m. M, 2, and 2. All right, so going back here, one factor is m plus 2. The other is m plus 2. And you need to remember to bring down that 6 to be a factor in our factored form. We could also write this as 6 times m plus 2 squared. Because we know anything to the second power is itself multiplied by itself twice. So 6 times m plus 2 squared. We're going to look at one more example. It's not a quadratic, but we can use a similar process just to kind of extend the idea and the pattern that we've been using. So we're going to look at 3x cubed minus 6x squared minus 45x. All right, so looking at this, you might think, oh, this looks complicated. I haven't seen a power of 3. I don't really have my ax squared plus bx plus c standard form. So let's do what we've done in the last two examples, just as a pattern recognition, and keeping with that pattern. So is there a value I can factor out of 3, 6, and 45? Well, that value would be 3. So we're going to take out the 3. And if you notice, what else do all three terms have in common? They all involve an x. So we can also factor out an x along with our 3. In doing so, our remaining expression in our parentheses would be x squared, because 3x times x squared gives us 3x cubed, minus 2x minus 15. We're going to factor what's in parentheses, that expression using our generic rectangle. X squared, negative 15. Multiply our two terms. We need something that multiplies to negative 15x squared and adds to negative 2x. Negative 5x and 3x. And we find our dimensions. If I pull out an x, this is 3, this is negative 5, and I'm just going to check to make sure those make negative 15. All right, let's finish this off. Our last example of writing our factored form. X plus 3, x minus 5. Those are our two factors from our generic rectangle. And now this time, we're going to bring down 3x. So this is our final form. Although we started with something that looked very different, we noticed through our process of factoring completely and factoring out that 3x initially, we could use our same process. And that is factoring quadratics completely.